Welcome back to International Finance. I am Andy Kim. We've been going through Chapter 6 of Eun, Resnick, and Chul-Loon, International Financial Management, which is about purchasing power parity, the force behind the FX rate changes. Can you forecast FX, right? And then we've been talking about purchasing power parity in terms of what is that? The law of one price kind of things, Big Mac index, all these kind of things. Talking about inflation that drives purchasing power parity. Well, we have to be, the guest of Irving Fisher, right? Irving Fisher. By the way, it does not seem to have anything to do with Ken Fisher, the very famous investor in the world right now. But this is a Yale professor 100 years ago. And then he's really one of the founding fathers of the monetary economist. In that sense, we'll see this kind of discussion later on. And then, so the increase, right, in the expected rate of inflation will cause a proportionate increase in the interest rate in the country. That's the idea, okay? Your interest, right? When you save in your bank or invest in your US treasuries or anything, you want to get compensated at least as much as the inflation that you anticipate, right? And plus some real interest rate that you want to get compensated, right? So you want to get compensated at least as much as the inflation. For the US, the Fishery effect is written as this. 1 plus interest rate in US dollar terms is nothing but 1 plus rho of US dollar times 1 plus expected value of pi of US dollar. And you see what is the inflation rate that you expect. That's this guy. Expected value of inflation coming in. Okay, right now is the good time, the best time to talk about that expected inflation, because the Fed chair has been talking a lot about this inflation, and then the investors in the market has been talking a lot about this inflation coming in or not with the quantitative easing and then all these kind of expensive, right, fiscal policy to help those people get affected by COVID-19 pandemic situation, right? Otherwise, if they don't do this kind of expansionary fiscal policy, everybody will be screwed up like in Great Depression, and we will face total disaster, Armageddon, right? But thanks to this, expansive fiscal policy, we are, having a lot better times. And then, economy-wise or stock market-wise, right, it has been surging up like crazy, right? Historical high points these days, right? Anyway, so that's why we've been talking about this inflation getting in, right? Is this market in a bubble or not? Okay, as inflation gets in, right? We can, with this too much money too much liquidity, they say, too much money in the system, the price level may take off too much, right? Those concerns about the inflation is legitimate, and the people have been wondering about it, right? And then that's something you have to pay attention, right, for your midterm exam and your final exam as well. And then somebody may be covering this in your current issues, right? It's one of the fantastic topics that you can cover. Anyway, so that's expected inflation. And another part over here, rho, is, what is that? The real interest rate. Why do we say rho? That's real rate, real interest rate. That's why, Greek letter rho. So if you do the math, you will realize that it should be nothing but 1 plus rho plus the expected inflation rate times rho times this expected value of inflation rate. But you see this last term is a small number times small number, which means extremely small number. So you can ignore this guy so that it's going to be like something like this, right? So plus you have 1 on both sides of the equation, cancel each other out. What is left in the left-hand side of the equation is your nominal interest rate. and right hand side should approximately your real interest rate plus expected inflation, your real interest rate. Did I say right? Plus expected inflation rate. Good. Where rho is the equilibrium expected real interest rate. Yeah, like this. Good. So the next slide, international fishery effect. Okay, we can tease out this one based on this formula. If the fishery effect holds in the US and it holds in euro, then what do we have? 1 plus inflation, the interest rate in US nominal should be like this, and 1 plus interest rate in euro should be like that. And if you, okay, and if real interest rates are the same in each country because of unrestricted capital flow, okay? Unrestricted capital flow. Nobody blocks you, okay? You, hot money, you cannot go into our country because we hate you. Nah, if there's no such restrictions, right? Like transatlantic, flow of money is just almost like this, right? Capital flows quite freely, frictionless world, okay? Transatlantic. So in that sense, the money will be flowing quite naturally to the country where it gives you a higher interest rate, okay? Real interest rate. So until when? The money flows one country from euro, let's say, euro real interest rate is 1%, whereas the US it is 2% real interest rate. Where will it go? The money will go from Europe to US in search of better real return, 2% as opposed to 1%. So money flows over there, so that over there in the US market, the real interest rate will go down, whereas in the euro, the real interest rate will go up to attract more money. And then over here is too much supply, so that the interest rate of two different countries will balance each other out until the investors will be indifferent. That's the equilibrium concept. Indifferent between these two countries, US versus Euro. Okay? That's where those real interest rate will equate each other, will be equal to each other. That's what is happening in this equation over here, right? So they are identical. Okay, let's assume that, right? Then what do we have? Then we get the international Fisher effect, like in this equation. So this guy divided by that guy, right? So did I say correctly? Or euro, 1 plus euro, right? Interest rate, okay? Sorry for confusion. And then, right, this guy divided by that guy, okay? So numerator and denominator, okay? Right? And then should be equal to this guy divided by that guy. Make sense? Yeah. So on your right hand side, you will have this one, okay, on as a numerator, and that guy as your denominator. Aha. Right. Now what do you have? We assumed this row is identical, right? So what do you have? The same guys multiplied and divided by each other, cancel each other out. What you're left with is this part, which is the ratio of 1 plus your expected inflation rate of two different countries, right? Numerator country and the denominator country. Anyway, so that's how it works. The international Fisher effects, okay, the relation. Now, what? Okay, based on this, leftmost and the rightmost, okay, move down to the next slide over here. But let's do some mathematical trick, mathematician's favorite trick. Look at the equation and subtract the same number, -1. That's the same thing, right? So that's what's happening over here. Why do we do this kind of manipulation? Well, just let's see what happens. So if you do the math, on the left-hand side, it will be like 1 plus interest rate of euro minus 1 because of this, and minus US interest rate, okay? So these two cancel each other out. And so that it will be simplified like this. And then right hand side, okay, minus 1 means your numerator will be 1 plus this guy minus 1 minus the expected value of your US inflation rate. 1 minus 1. Okay. What do you have on your numerator? Expected inflation rate in euro minus expected inflation rate in US dollars. Okay, fine. Then what? Then what? We want to simplify further your left-hand side and right-hand side together, assuming US interest rate and US inflation rate are small enough, right? Then the numerator will go to 1, okay? We'll go to 1 in both sides of the equation. So that's why I say approximately, like tilde, right? Tilde. So left-hand side is interest rate differential between these two countries, and then the right-hand side is inflation rate differentials of these two countries, right? Fine, that's something we already know, isn't it? Yeah. But what we want to do one more step is just add back those row, okay, real interest rate in the left-hand side or the right-hand side of the equation, just to interpret one more time. This guy is nothing but the interest rate, nominal interest rate in euro. And that guy, if you parenthesize, then it would be like plus, right? This is nothing but interest rate of the US, right? Okay, fine. We are just rewriting it. And then this is nothing but expected value of the change in the FX rate, change in exchange rate, okay? The small e expectation. Small e expected value of it, approximately it is the interest rate differentials. I should be careful in my pronunciation. Interest rate differentials. That's something called international fishery effect, okay? The international fishery effect suggests that the nominal interest rate differential reflects the expected change in exchange rate. Okay, if the interest rate is 5% in the US and 7% in euro, the US dollar is expected to appreciate against the euro by about 2% per year. That's the intuition over here. Okay, so that's that. If we move down, one more time, if the international fishery effect holds like this and interest rate parity, right? IRP holds, then what we have? Forward rate over spot rate, okay? And we have right-hand side, which is identical to this one, right? And then the forward rate purchasing power parity holds true because these guys are true, are the same, and then these guys will naturally follow, okay? So that this guy comes down over here. Your forward rate premium can be explained by the expected inflation rate differentials. Okay, so that's forward PPP relations that we can infer out of it. If international fishery effect holds and the IRP holds, then we can see that these relation holds, right? And I know a lot of mathematical formulas and equations go on, but please bear with me. Don't lose thread. It's all about numerator and denominator and then dividing by the same thing or multiplying by the same thing or subtracting the same thing on the right, the both sides of the equation and things like that. Anyway, the IRP over here, right? And then subtracting 1. Okay, why? Well, because we want to interpret this guy as a forward premium, right? Forward premium. And then right-hand side is this. And then if you do the math, you will realize that forward premium or discount can be interpreted as interest rate differentials, right? Expected change in FX rate is forward rate minus spot rate over spot rate. Forward expectations parity relations holds true. We call it forward expectations Parity, FEP. Any forward premium or discount is equal to the expected change in FX rate. Okay, so that's that. That's something we already talked about in IRP section in last week, right? Nothing new. So what are we up to, right? I told you before in the beginning of this week's class, the chapter 6 is about this diagram. We are trying to understand the force behind FX rate changes. Can you forecast this thing, right? All these things are determined in the equilibrium in economic theory. Forward rate is nothing but the expected future spot rate. And that forward premium or discount or expectation of FX rates going upward or downward, right? Appreciating or depreciating. You can interpret those things, right? As an interest rate parity relations, the interest rate differentials, or forward purchasing power parity relations, forward PPP. It is related to your Fishery equations, the differentials in your inflation rate, assuming that your real interest rates are identical across different countries, assuming free capital movement, frictionless capital market, right? Then this Fisher equation and the Fisher PPP holds true over here as well. And what do we have over here? This is forward expectations parity, right? Forward expectations parity. Well, your price or FX rate movement, right, is nothing but the expectation of your, driven by expectation of your FX rates driven by your PPP relations or international Fisher equations relations, right? Holy cow, a lot of complicated network that you can, network relations, but it's, interest rate parity first of all, and then added to it purchasing power parity relations, because we have Fisher equation, Irving Fisher relations holds true. That's it, nothing but that it. And then this is FAQs in your CFA exams, right? So get ready for that. Anyway, so expected rate of change in FX rate as interest differentials. You can interpret it this way, okay? And then you can interpret it, right? If expected rate of change in an exchange rate as inflation differentials, right? IRP or PPP or forward PPP. Given the difficulty in measuring expected inflation, managers often use a quick and dirty shortcut like this. Interest rate differentials approximately inflation differentials. That's perhaps why I my pronunciation, interest rate, inflation rate, jumbled up. But sorry if I just mispronounced it, but I mean this, right? Anyway, so that's that for now, and thanks for your watching, and like and subscribe right now, please. Thank you.